Okay, so this is going to be a review. You don't have to watch this if you're pretty good at REQ, but if you need more help with REQ, we'll start off with this. But the first thing we need to do, guys, we need to define something. The first thing I want to define is a simple circuit. So this is a simple circuit, and the reason it's so important, guys, is that it's really easy to solve. So a lot of times, you could have any circuit in your quiz, and you're like, oh my goodness, I really just wish I had a simple circuit, that gives you some voltage supply, has resistor, and it has current through it. And you can use Ohm's law to solve a simple circuit very easily. V equals I R. Okay, so that's great. That should be pretty easy. But in life, like we know, not just like in physics, things are often more complicated. So you might have something that looks like this. And this thing, guys, is a series circuit, and it's just one step more complicated than a simple circuit. But in the end, we'll call it 2 or 12, whatever. In the end, it's not that hard to solve, and you guys should be pretty experienced with that. But there's a new way to solve it, and once again, this is not new for most of you, but I've had some reports that people were having problems with this. It's called equivalent resistance. I think it's resistance like that, but let's hope. Okay, so and it's REQ, and it's often just referred to as REQ. And basically, it says this: that any formation of any formation. Come on, you can write formation of resistors can be simplified. Mm, where's my eraser? Can be simplified. Well, how is that? Well, the first thing is just to define the REQ. So you can do this. Find the REQ of this. Now, this is a series circuit, guys. So REQ of a series is just R1 plus R2 plus R3 dot dot dot. And we know by looking at this, we only have two. So it'd be this one plus this one, and that would give you the REQ. And then what you do is you'd bring that REQ up to this circuit, and then you just make this your REQ, this your REQ. This is going to be the voltage of your battery. This is going to be your current. This is very important. This is your current through the battery. So that makes this particular formula really important. So, okay. Um, so that's one approach. The next one is going to be parallel circuits. Let's do parallel real quick, and I'm going to erase all this. So guys, parallel is not that much different. If you have a parallel circuit, that just means you have a junction. And let's say you've got R1, R2, and you've got a voltage. Okay, so what's going to be our REQ? Well, it's different than a series, but this circuit too can be simplified using the REQ method to this. Well, you may be saying, Mr. Shaw, like many of those infomercials you see on TV, this is too good to be true. But it's not. It is true. So we can say for a parallel circuit, we can say 1 over REQ equals 1 over R1 plus 1 over R2 plus 1 over R3 dot 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 to infinity, however many we have. We only have 2 here. Let's give ourselves some values so we can get practice. Let's just say this is 2 ohms, and let's just say this is 3 ohms. Okay? So this is going to be, let me pick a different color, green, 1 over R EQ equals 1 over 3 plus 1 over 2 ohms equals, now we have to have a common denominator, it's going to be 6, so this is 2, 6, 3, 6. Did I say that right? Yes. So you're going to get 5/6 ohms. Now you see the ohms on the bottom. That should give you a signal immediately that something is the matter. We need to flip it. And a lot of people usually do like cross multiplication, but I just flip. I go 1 over REQ equals 5/6, and I just say REQ equals 6/5 ohms. And there we go. Now, an interesting thing, guys, to note, and a lot of people saw this and observed this in the lab, is that the REQ, this REQ, which is 6/5 ohms, it's going to be less than any of your resistors. So like it'd be less than R1. It's also less than R2. Or what I put greater. Silly Mr. Shaw. So yeah, this needs to be the opposite way. It's less than those. And that'll always be. No matter, the resistors, the REQ is always going to be less than all the resistors. And that's pretty interesting. Okay. So let's look at a more complicated one. You may be saying, Mr. Shaw, this seems so simple. Well, let's look at one of these hard ones. And let's say this is a circuit right here. And let's say this is 2 ohms. And let's say this is 1 ohm. And let's say this is 3 ohms. And let's just say this is 4 ohms. Okay, so you get the hint. This is 5 ohms. This is 6 ohms. Well, Mr. Shaw, let's do this Ohio style. So I'm going to get out my blue pen. Let's make it my different blue pen so it shows up. And let's find the REQ of this. So the first one, guys, segment just this part. Do you see you have a parallel circuit here? And you can tell it's a parallel because of these junctions. So 1 over REQ equals 1 over R1 plus 1 over R2, which is going to be equals 1 over 2 plus 1. So that's going to give us oh, geez, I can't believe I'm having this brain freeze. That's going to give us 3/2, and that's ohms on the bottom. And you flip it, you get 2/3. So this first REQ is 2/3. Okay, great. We got the first one done. Now let's take a look at the next one. And let's skip a couple steps because we're getting a little better. But we're going to do this one. This is a parallel circuit right here, and you can tell by the junctions. Okay? So you get 1 over 3 plus 1 over 4, common denominator 12, so you get 7 over 12 equals, the REQ for this one equals 12/7 ohms. Great, easy peasy. Now we're to this last one. Let's find the REQ of this section. Okay, so it's 1 over 5. I'll use this mark that's right here randomly. 1 over 5 plus 1 over 6. And that's going to give us 11/30, or also 30 over 11 ohms. So now, let me redraw this, what this actually looks like. I'm going to bring this down for a second. And I'm going to draw this. Now, where we used to have 2 parallel resistors here, now I just have 1, the REQ. Where I used to have 2 parallel resistors here, I just have 1, the REQ. Where I used to have 2 parallel resistors here, I just have 1, the REQ. So now I've got this. Sorry about the battery looking so crappy. And now I have my REQs. I'm just going to list them. 2/3. Pick a different color. 2/3 ohms. And this one is 12/7 ohms. And this last one is 30/11. And now you should see that our REQs have made an interesting circuit, because this should be very simple. This is a series circuit. So again, what are we going to do with this series circuit? You just add them up. I am not going to try to find the common denominator, but your new REQ for this whole circuit is going to be 2/3 plus 12 over 7. 7, I said. Plus 30 over 11 ohms for all that. And then you get the value. That's the new REQ. And basically what you've made now, you should have made with this, once you do this last step, you make a simple circuit. You should make a circuit that looks like this, with one REQ in this. And remember guys, the purpose of REQ, what helps us find some things. It'll help you find your current through your battery. And then once you get your current through your battery, then you can start solving for other fun things if you're skilled enough to. Okay guys, hopefully you enjoyed this, didn't waste your time.